So, hello everybody, my name is Mikhail Svetkin and I'm software engineer at Cisco, and today we are going to talk about QProperty. Yep. Okay, yeah. Something wrong with the slides, they don't want to go next. Yeah. Okay, now it works. Yeah, so the QProperty is a new class which is going to bring us a QML property binding into C++. This class is going to be part of Qt 6 and it's going to be one of the major features of the new release. Before we go into deep dive in QProperty, first of all, we need to refresh our knowledge about QML properties. What does it do? What does it provide to us? And what we can do with that. After that, we can take a look how we are going to have the same features in C++ and how it will affect the Qt framework itself. So QML property binding. Just a fast refreshment that QML is a declarative language designed to describe the user interface of your program, and the JavaScript is used as a script language inside of the QML. QML property binding was one of the success story of the QML itself. It allows to write a UI very easier and more readable way. So I hope we will get the same things in C++. So let's take a look at a simple example. Here we have two rectangles, one inside another one, and one of them has a fixed geometry, height and height 200, and the second one has only height, and the height is kind of referral to the root element. So if I run the example and just try to resize the object, you will see that wherever I resize the white rectangle, the blue one is also resized. His height is calculated. It depends on the white one. So that's basically what is the QML property binding is. The QML property binding is designed to bind one property to another one. And in that particular example, the height of the blue rectangle depends on the height of the root rectangle. So that's what property binding does. It binds one property to another one or to the multiple one. So in that, as I said in that example, the rectangle height depends on the root height, and every time root height changes value, it will immediately change the rectangle blue rectangle height as well. So in the terms of the QML, the root height would be a binding expression. Binding expression is always start as from the column. We can say it's a binding operator, and right after the binding operator, we write a JavaScript expression that evaluates every time when one of the properties inside that binding expression will change. So the binding expression could contain like a simple mathematical calculations, or it could call the separate functions, or you can write the conditions by using a tenor operator, or you can write a huge lambda and make a lot of conditions and structure your code a bit better. You can also call the functions, and then in that case, your property is going to depend wherever you use inside that function. So let's take a look how to change the property binding in runtime. So in that particular example, we have a rectangle which has a height 200, and his height depends on the height is by multiple by 2. If we want to change the property binding, there is two ways. First of all, is simple assign operator. It destroys a property binding and assign a constant value. So in case where the keys on space pressed, when we press a space, the height is going to assign height multiplied by 3, and it will never change again. If we want to create a new property binding, then we need to use a function called QBinding, and that's create a new binding and allow us to continue. Height will be depends on the byte, but we just create a new one. Let's take a look what else we can do with QML properties. Every QML property provides us a signal. It's when you define the property, it's implicitly create a changed signal for you. Then later in your program, you either can subscribe on that signal, or You can use the mechanism of signal slots in C++ to connect to that signal or do something. Basically, the signal always contains the same name. It's a name of the property plus a change keyword. Yeah. That is one of the useful features in QML properties, because you don't really want always just assign something, but you always need to somehow communicate, understand that your property changed and you want to do something. That's one of the way how you do that in QML. Yeah. There is one more feature of the QML properties. It's called alias. So if we take a look at this particular example, we have a component called myText. Inside of this myText, there is a rectangle and text. And we use the myText a bit later, and we bind the text property to the input of the root property. So in that case, we propagate the text from the myText to the actually label inside of that myText. That's kind of useful. It's allow you don't write the setter or getter functions as we do in C++, just to say, oh, I want to use that property, and that property is the alias to that property. Yeah. Before we go to the summary of the QML property feature, because that was almost all important features of the QML, we need to take a look one more thing, is when we actually evaluate our bindings expression, because that's kind of magic. We don't really understand how it works. So I wrote a simple example, and that example, there is P1 and P2, two Boolean variables properties. P2 depends on P1, so wherever P1 changes, P2 should be updated. And there is a callback called component onCompleted. This is basically a callback which is always called after the constructor in terms of C++. So wherever the item created, the component complete should be called, and then we can start to work with our item. So in that particular case, if I run the program, first what I would see the debug output as the evaluated binding expression. That means that the binding is actually created during the construction of the item, and only when it's ready, we can use it. So in our case, it would be P1 false, P2 false. Then when we change the, say, P1 true, it immediately will reevaluate the binding for P2 and assign a new value to the P2. In that case, we will see that the P1 becomes true and P2 becomes true as well. That's kind of an important thing in terms of how the QML works and what you can do with that, because some of you can look at the example and think, we actually don't use the P1 and P2 for anything. We don't change any white, height, color, or something. But the still QML engine is going to evaluate these property bindings. And the reason is for that because QML engine actually doesn't know what you're going to do in your lambda or wherever you want in your binding expression. You're actually able to assign new white or height inside, and then you will trigger the system should be updated. So that's why they always initialize all property bindings in the beginning, because they don't know what you're going to do inside, and just to make sure that everything works. Yeah. There is a second feature. It's called, I call it partial evaluation. I didn't find the official name for that, but let's take a look at the example. Here we have a 4 properties: name, location, remote, and event. An event depends inside in his lambda on remote, name, and location. So if remote is true, then we get name plus online. If remote is false, then we get name plus location. So if we run that program, we will see that first of all, the event will contain Sendesite, town, Kensberg. If we say remote true, then that automatically will trigger reevaluation of the event, and it will print the next time it will print online. When we assign location, change the location from Kensberg to Oslo, that actually doesn't trigger anything, because your property binding is not anymore depends on the location, because even though the location was changed, the remote is still true. And in your binding expression, you are not going to go to the line return name plus location. So in that case, it's kind of a partial evaluation of your property binding. So then if we assign the name, then we will get the event will trigger the binding expression is dirty. We are going to relate it again, and then we will get a new event. That's a very important part of the QML, and it will be also an important part in C++, because you need to understand when you write a huge projects, you are going to have a lot of properties, and one property might trigger millions of other properties to relate their value, even though they don't use it, even though they don't change any colors, white, height, they don't make any visual changes. So that's very important to understand, because otherwise you can end up with the change in one thing can change rest of the world, even you don't see it, but it will take your CPU time. So let's go to the small summary of the binding, QML property binding. So it's a simple syntax. It's very nice and readable. It supports change the property binding in runtime. It supports partial evaluation. It's create implicit value change signal. It's also support aliases. So that's kind of common QML property binding features. Let's see how we can do the same in C++. So that's a part about the C++. Please be ready if you have any questions about that part. I assume that you can just write it immediately, and I will try to respond, because the first part is kind of tricky. And if you don't understand the first part, it may be hard to understand the next one. So please, if you have any questions, write it, and I will try to respond immediately. Yeah, good. Then let's take a look at this. This is a simple C++ property binding examples. It's the same as we used to have before in QML. So we have two properties. One is the P1, the second one is P2. P2 depends on P1. And if we run the program, we will see, first of all, P2 is false. When we change the P1, the P2 becomes true. That's kind of a magic. And the example is perfectly valid. If you copy paste it and run it, it will work. So few things we can notice. First of all, it doesn't depend on the Q-core application, QGO application, or any Q application. We don't use any signal slots. We don't use the event loop. So it's completely separated implementation. It doesn't, you're able to run your code without the Qt itself. Just basically copy paste a few headers and it's almost going to work. Yeah. So let's compare to that with the QML, what we have in QML and what we had in C++. So as you see, the syntax is pretty similar, except that in C++ we need to call Qt make property binding, we need to call P1 value, P2 value, set value, but actually there is no any technical limitations in terms of C++ to first of all remove Qt make property binding. It's kind of, it doesn't support it right now, but I'm quite sure it will be one of the interesting features to request, I think. Instead of writing the Q make property binding, just assign lambda. The second one, we don't really need to call any P2 value or P2 P1 value. It's basically there is implicit constructor which will returns the value. So we can eliminate this as well. And the same for the set value, we don't really need it. We can just eliminate it as well. I didn't eliminate the P1 value because currently there is no technical limitation to remove the P1 value, but it just doesn't support it. But we can assume that it will be at some day, or somebody will push a patch. Yeah. So the same we can do for P1 set value. We can remove it and just assign it true. So if we now compare what we got in QML and C++, it's almost the same. The difference only is that in C++ we capture everything in Lambda by reference, and in QML we don't do anything. It's automatically captured by QML engine. There is advantages and disadvantages of that syntax in QML. So first of all, for example, if the item doesn't contain P1, then then the QML engine will find in the parent and the parent and the parent of that item and go up until it will not find anything. In C++, it's more straightforward. It's C++. You set what you want to capture, then you get it inside your Lambda. So it's kind of, I think, easier in C++. But let's take a look a bit deeper in the C++ example and see how the binding evaluation works in that case, because that's a bit different that we have in QML. So I took the same example as we had before. I just added a bit more debug information. And let's run the program and see what we will get. In the QML, the first line as an output we get was evaluation binding expression. In the C++, we actually don't get anything. We get the P1 false. So we created the binding, but the binding was not evaluated. When we call P2 value, we actually see that there is evaluate binding expression, and then we get the value. So it's kind of a bit, it looks like the evaluation of the property bindings in the C++ is kind of lazy way. We don't do it unless we want it. So let's just check our theory that when we say P1 set value true, in QML we also saw that the evaluation binding expression was immediately printed. In that case, in C++, it doesn't happen again. So P1 true, and only when we call P2 value, then we will evaluate the binding expression, and then we will print the true. That's one of the main difference between the C++ version and QML version. In QML version, as I said, when one property triggers his change, it can end up to trigger other millions of properties, depends on your project and how you wrote it. And C++, actually nothing is going to happen unless somebody wants to read that property. That's kind of lazy evaluation called in C++ way. Yeah. Let's take a look at that example a bit deeper and go step by step and actually understand what's going on here. Because it still looks like kind of magic, how the P1 and P2 knows about each other. What is their connection? We don't see anything in the source code. So let's take a look what the Qt make property binding does. It's constructed property binding from a lambda. It's assigned it to the property. And it's also, when we first time create the binding and assign it to the property, it's marked as dirty because nobody never evaluated binding. We don't know what's the result of that binding. So, but we don't call the lambda to check it because we don't need it. Nobody didn't ask it for that. So the next step, when we call P2 value, the property inside check, is there a property binding? Is there is a property binding? Is it's dirty? Then we actually need to evaluate the property binding. So in that case, inside the P2 value, the P2 kind of marks that I started in the global variable. It marks, well, I started the evaluation of my property binding, and then we call the lambda. When we get to the lambda and when we call P value, we know that there is a global state somewhere said, well, P1 or P2 is going to evaluate his binding. That's why how P1 actually can check is somebody started evaluation process. If that, then probably I will understand that this property in the global variable is actually, I'm going to be the source for that property. So the P2 stores that it depends on P1, and the P1 stores that it depends on P2. Opposite, yeah. Yeah, when we call the P set value true, we update the value in P1 and we check if somebody depends on P1, and we know that it depends on P2. It requires to P2. So then we mark that binding as dirty, and the next time when P2 is going to evaluate the binding, next time when we call the P2 value, then it's going to check if the property binding is dirty, and then repeat the step as previous one. Evaluate the bindings, mark that it started the process and everything. So that's how it works. If we expand this p-value function just in a bit of the, I would say, pseudocode, but it's kind of real C++. I kind of simplified the version what is in the Qt, but it's just easier to understand. So if you take a look at the P2 value, what it does, wherever we call the P value, it checks, is there is a binding, is the binding is dirty, clear observers. So we want to destroy it because we don't know what we are going to depend on next time when we call evaluation. So we mark in the global static thread local global variable. That's, well, current binding is that one. We started the evaluation of P2. Then we call the lambda. When we call the lambda and we call the P1 value, the same, we check is there is a binding, is the binding dirty? In our case, the P1 doesn't depend on anything, so it's actually go to the next step. You check, is there a current binding? Well, yes, it is. Then we create an observer. We mark that this observer observed the property this, in that terms it would be P2 or P1. And that's how P2 knows that it depends on P1. At the same time, we save that observer inside the P1, that P1 knows that it's actually it's a source for the P2 variable. So that's basically how it works. There is no any magic. It's a pure C++. There is no involvement of meta object compiler or any other Qt macro stuff. So it's a valid C++, C++11 actually code. So just a question: is anybody understand how it works, or it's hard to understand how it works? Because if you didn't understand, I can try to explain again that part. You feel free to unmute and ask if it's hard to type in the room. So I would accept it as everybody understand how it works. So as I said, that's basically very, very simple way of implementing this. I'm not sure why it wasn't implemented many years before. Maybe because we didn't have a thread local in the standard, but it was from C++11. So anyway, it's a cool feature actually. So let's take a look how we implement the partial binding evaluation in the C++. I took the same example, just rewrote it from the QML to the C++. So again, we have 4 properties, 2 of them name and location. Third one is a remote, and then we have an event which depends on all of them. At the same, and again, there is the same condition. If the remote is true, then we use only name and line. If it's false, then we use the name and location. So let's just go the same way as step by step and see what's actually going on. So the same, Qt make property bindings, create the property bindings from the binding expression, in that case lambda. When we call first time event value, we trigger first evaluation of the binding expression because the binding was marked as dirty. The next step, when we try to read the lambda, we check if remote is false, then the event depends on remote name and location, like in terms of property bindings. It depends on 3 properties. And we call the not dot value, but there is implicit operator for convert them from the property to whatever they are. So in that case, we know that event property depends only on 3 properties right now because, well, access only 3 properties. When we say remote true, and we know that the remote property knows that it is a source for the event property, we mark the binding as dirty one. The next time when we call event value, we try to evaluate the lambda. Before we started to evaluate the lambda, as we saw in the previous source code, we kind of clear the observers. So we don't really know what is who is and what depends on in that case. So we started from beginning, from the scratch in that case. So when we call lambda again and remote is true, then we construct the string only by using the name. That means that location was never called and location never registered himself as an observer. So that means if we change the location, it will not mark the binding as dirty because location actually doesn't know that it's involved in something. And the next time when we print the binding is not dirty, we just read the cached value wherever it was. In our case, it's in the CTEC town online. So the next time, if we change the name, for example, we know that the name knows that it is a source for the event, and when we read when we try to read the value again, then we see that the binding is dirty, and then we try to re-evaluate the binding expression. So kind of very simple way to do it. By the way, maybe some of you guessed how does a partial binding evaluation and the binding evaluation works in QML. Actually, it works the same way. They don't, as far as I know, they don't check or introspect the IST tree of the JavaScript or anything. They just do basically the same way. So let's go next. Let's see how the Q property provides the signals in terms of as we had in QML. So basically, you're going to have two functions. One is the onValueChanged. The callback which you pass to the onValueChanged will be called wherever the value changed. And the subscribe is kind of the same, but only that you call the lambda when we just pass it. So it's immediately called the lambda which you pass it. So if you want to subscribe and you want to do something with the current value. If we compare to the QML property signal syntax, well, it's kind of the same. The one thing is there that in QML, if you want to subscribe multiple times on the same signal handler or signal, you need to use the special type QML connections. In C++ Word, you're allowed to subscribe as many times as you want. The only one difference in that case that you see there is after signal handler 2, subscribe handler. So these objects, they're like a guards. They keep the lifetime of the wherever you subscribe or you want to call your callback. When this object dies, you will never call your callback or lambda again. So that's a bit different between the QML and C++. Also important to know that it's in the current implementation of properties, you're not able to pass or use the same syntax as you do in the signal slots. You cannot basically say on value P1, on value change, I want to subscribe on that object and call that slot. That's currently is not allowed. It's not like there is some technical limitation, it just have not been done. So probably I think somebody will implement this. Yeah. So if we take a look how we change the property binding in runtime, in the C++, there's a few functions. You can take a binding, which will just disassociate the binding expression from the property. The binding is still kind of valid, and if we we've changed the location to say Oslo, that the binding will be marked as the dirty one, but it just doesn't trigger the revelation on anything because there is no one property who used that property binding. Then we can always assign it back by calling set binding to set a new binding. And if we explicitly say set the value for the event, then the binding destroys. It's kind of similar what we have in QML. So if we just compare the examples, we'll see that syntax is pretty similar, the same. Unless that in QML, actually, if you want to create a new binding or like restore the previous one, you always need to create a new one. There is no way how to keep the binding in the QML. So that's a difference. Yeah. If we look at the property aliases, so it's pretty similar as we have in QML, and QML have a special keyword alias. In the C++, we have a special property alias class. Basically, it's just take the reference pointer to the property. So in that particular example, as we have in the QML, we have a myText, which encapsulate the text, but to provide his property to the public API. So then you're able to subscribe, or you can change the binding, or you set the value, or wherever you want. Yeah. So if we take a look in the summary of the features of the Q property, then we will see that it still keeps the simple syntax. It supports partial evaluation, it supports aliases, it provides signals, which is not kind of signals, but just the callbacks, still fine. It supports change property binding in runtime. The extra feature is lazy evaluated to compare to the QML. And there are a few also aspects that it doesn't depend on Q event loop, it doesn't depend on Q core GUI or Q application. So you can use it in your project, even though you don't use the Qt itself. It will perfectly fine work with your custom types. You don't really need to do anything. What it doesn't do is doesn't provide the simple integration with signal slots. So there is no way for now. I'm quite sure it will. It only supports only single threads. So you're not allowed to make a binding from the properties which is live in a separate threads. I don't know, was it made like this intentional, or is it just because nobody didn't think about it? But I know that the C++ Folly library, open source library from Facebook, they implemented the same thing, but they allowed to use the properties from the different threads in one property binding. So should be fine. I don't think that Qt is going to do that, but maybe they will. Okay, the next step is what I propose is take a look what's actually happened, what is going to happen with the Qt itself, because that's kind of a new API and we curious how it's going to be integrated inside the Qt, because we as the developers who use the Qt, then we kind of might be affected, because the Qt 6 is not going to keep the promise of don't break the ABI or API capability switching from the Qt 5. So the API might change, but it doesn't have to, but might. So the current status in the dev branch contains two approaches. One of them is provided in new Q private property macro. It's already merged in dev, and all changes in Qt kind of done. It's not changed any other current classes, but you can use it if you want. And there is a new way how to do that. It was proposed kind of recently by Lars. It's a new keyword to the Q property statement. It's called bindable. And we will take a look both of them and compare what one is better, what is worse, and how does it work in general. Because as I said, from developer's point of view, I would like if the Qt 6 will kind of keep the ABI and API capability, that I don't need to change all my source code just to get that feature. Yeah, so let's take a look from the first one, option 1. So let's take an example of the simple class in Qt 5. Let's take a look at the Q object. Q object has a Q property statement which defines there is one property object name. It's provides two functions to read and write, object name and set object name, and it's also has a signal object name changed. So pretty simple example. We already get used to the Qt, I would say, magic with the macros, and it's used by meta object compiler to generate meta type information, and that's basically it. So let's take a look what can be happen in Qt 6. It's not decided yet, but there's still ongoing conversation. But let's take a look. So in Qt 6 on the right side and Qt 5 on the left side, we can see there is slightly difference between what we had and what we is going to have or can have. Yeah, I just highlight the changes. We see that in the private object, we changed the Q string to be Q property. And in the public class, we see that the Q property is gone. There is a Q private property. It's kind of unreally understandable syntax. What do we pass there? Nobody can guess unless you go and see. We also don't see any more object name and set object name functions. We don't have a signal as well. And there is some kind of weird three macros: Q private properties begin, property implementation, and end. So let's take a look what they do by expanding one macro by one. So yeah, before we expand the macro, just a few explanations. The Q property macro First of all, it's a mock token. When the meta object compiler reads the header, he will find it, he will understand, well, that is my property. I need to register that in the meta type information. The second purpose is to provide a wrapper for Q property or hide the implementation of the Q property from the end user to keep the API. We will talk a bit about that a bit later. But in general, let's expand the Q private property and see what does it do. So if we expand the Q private property, we'll see there is a structure, this kind of weird naming, cute underscore property underscore API underscore object. That structure actually replicates the Q property API. That structure doesn't contain any members. It's basically the size of that structure should be 0, but it will be only 1, because in C++ you cannot have a structure which is 0, at least 1. So, and also we see that there is kind of set object name. So it's also provide that by that macro. So let's expand the 3 last macros and see what does it do. So if we expand the macro, we will see that actually it's a union. We see a declaration of our object name, and is that structure. Some of you might ask, why is it a union and why it's like that? The answer is very simple. The Qt doesn't want to, they don't want to grow in size of their objects or their classes. So basically, since the Qt property API object name structures is size of 1, and the rest of them, all other properties would be also size of 1, then, well, they can share the same kind of address space, since they don't contain any members and everything. So they don't want that every time when you create a new property, you will get extra 8 bytes for the pointer to that property. Yeah. But as we see that this this macro Q private property, it's give us a structure, but it doesn't give it's only declare the function inside. It doesn't provide the definition of the function. So if we go inside and take a look what's actually mock generate for us, that is his job to provide some extra helper functions for us. We will see what's going on. So that's how mock QObject.cpp could look like. So it will generate the set object name for us, the body of that function. It's very simple, just get the pointer to the private class, take the property and say set value, pretty fine. Then we also see that it generates the API or the body of the body functions for that weird structure, I would say. So if you take a look inside what's actually mock generates for that Q property API object name structure, we'll find a quite surprisingly interesting thing. So let's take a look at one of them. So the object name function. Yeah, so there are just 3 lines. First of them is trying to calculate offset from the object name. It's trying to calculate the offset of the property which we define in the union to the Q object itself. By doing, and the second line is kind of try to calculate that this pointer of the Q object itself, not that this pointer of that structure, but the pointer of the Q object. So basically, since the Q property API object name structure doesn't contain any members, it doesn't actually know where's the Q property or the private D pointer of the Q object exists. So it basically calculates it in runtime all the time, actually. Yeah, it's kind of tricky, but it kind of works. There are just few problems. First of all, the static cast of QTimer to the null pointer, like null pointer static cast to the QTimer, and then they get the address of the object name is undefined behavior. But that works in the QtQML. It's in production since release 2010. There is a class called static cast selector, something like that, and it's do exactly the same. It works. So the Qt claims that, well, on all modern platforms it works. So we can trust them, we can don't trust them, but that's how it is. The solution was proposed in the main list to replace this calculation by using offset macro, which is standardized and provided by the standard library. But offset doesn't support non-standard layouts. So in that case, when you try to use offset in that particular case, you will get a compiler error. Of course, you're able to ignore it. You can disable that error, but still, that's what you will get. And as I said, even though if you use the offset off and it's not supported, it still works okay on all the modern compilers. You don't need to do anything else. It's just work. Just disable the warning and it will calculate. But standard doesn't guarantee anything. It's kind of undefined behavior as well. Yeah. So if we take a look on the second, yeah. So since we calculate the property member offset by using undefined behavior, the calculating of this pointer is also kind of undefined. You cannot rely that it's correct. So, but as I said, it works fine all modern compilers. So you shouldn't worry about that. And it's 10 years in production. That's what we use nowadays. Yeah. So let's compare what the changes of the API of the QObject will become when we will switch to that approach, for example. So on the Qt 5, if we create the object, we had the three functions. We can get the object name, we can set the new object name, and we can call it signal, object name changed. Or when you call set object name, that signal will be immediately sent when the name is new. On the Qt 6 side, you actually will get the object name. You can get the set object name, then you can object name set binding when you provide the binding. You can subscribe on the value. You can just make a subscription. You can set a new value, and optionally can be supported the signal and object name. I didn't show it in the previous example because when I tried to implement the support of the signal, the example grows. It becomes very, very ugly to see in a slide. So just believe me, that's possible to do, but the source code doesn't look very nice. Let's go to the second option. What we can do with another proposal, which was made recently, it's still under discussion. But again, we go back to the QObject in Qt 5. So we have in private class, we have a QString object name, the QProperty macro, and we have two functions, object name and set object name, and we have object name changed as a signal. So in Qt 6, what we are going to have with the second approach is that basically the changes are happening almost only in the private class. You need to use QObject compact property macro, which will do some magic for you. And then inside the public class, you just need to use bindable keyword to say that, your properties support bindings. And you need to say which function give you that binding, or like give you support. So you see there is a new function called bindable object name. That's kind of a syntax which is Qt is kind of enforcing you. Wherever you want to create a bindable function, then you need to call bindable and then the name. So what do we get with the second approach? We have a new keyword bindable for the QProperty. We have a new API function, bindable object name. In that case, we don't get the QProperty, but we get the QBindable because this the same purpose. The Qt wants to keep promise of the ABI and API capability, so they just return you a QBindable, which is basically repeats all API of the Q property, but just hide that you actually get the Q property, that they can change it later, some internals of the Q property or something. Yeah. You will get 3 different macros. It's called QObject compact property. It's for capability with the old one code. If you use that, then the source code works the same way as it used to be. You don't really need to change anything unless adding a new function. Then the second macro is a computed property. It's for the read-only properties. It will not store any cached value inside the property binding or the property. It will always calculate it on the fly. Maybe good, maybe not. Question. Yeah, and there is QObject bindable property. This is meant to be used for the new code. And yeah, the question which macro Qt is going to use in their classes is also questionable, because in Qt 6 they allow to break the API. They can remove the functions. That's also fine, but I hope they will not going to do that, because otherwise we need to, I don't know what we need to do to adapt our source code to that. Yeah. Let's take a look just how the Q bindable object name function looks like inside. So it's pretty simple. Just get the pointer to the D to the private class and just say object name and basically everything down. That's what you need to do with the option 2. With the option 1, you need to completely change your class or how it looks like from the public. So if you compare, what do we get in? If we compare Qt 5 and Qt 6 and option 2, what do we get? We will see that basically you get the same API, you get the object name, you get the set object name, you get the signal, and you get the new function where you're allowed to call set a binding, subscribe and value change, set a value, or get the value wherever you want. Yeah. So if we compare option 1 versus option 2, in my opinion, the first one looks easier, that you just get your object name, you don't need to type or call a function, or the name of the function is object name. Bindable is kind of, I don't know, looks ugly for me. But then you kind of you can lose the previous API which you had before. So in terms of keeping ABI and API capability, the second option is much better, because it doesn't break the API, it doesn't break the API capability, so it's allow you to use a switch from Qt 5 to Qt 6 without any changes. Then the new feature is available for you. You still need to change your source code a bit, because wherever you call set object name, just as you used to have it, used to do it, then you will destroy the binding if you create the binding. So you need to change your code, but still it's like it doesn't break anything, but allow you to experiment with the new feature. Yeah. So when do we get the Q property? It's currently available in dev branch. Doesn't work everything. I had to modify the source code of the MetaObject compiler. I had to modify some internals of UQ property to make it work perfectly. But basically it's there. It's going to be arrived at the Qt 6.0. Originally it was planned for December, but actually I'm not sure that it will be in December, because of the, well, this Q property discussion is still ongoing, and nobody understands when it's going to end. So I don't know when it will be, but I hope soon. And as I said, the integration, how to integrate Q property inside Qt is still ongoing discussion. Should we break the API? Should we break the API capability, or should we just keep it as it is? And if we don't break the API and API capability in Qt 6, then the next time we can do it in Qt 7. So it could be in the next 13 years. So that's a question, what the Qt company is going to decide in that case. Yeah. So some useful links. The original inspiration of this Q property stuff is actually based on the article on the Wobak.com. It's a blog of the Meta Object Compiler maintainer, Olivier Goffat, if I spell it correctly. He wrote it in 2013 and he described how it can be done. And later, after 7 years, we kind of get it. So it's cool. And there is API design principle in the Qt wiki, when and how you're supposed to use Qt property. It doesn't actually say how you should use it in the user code or what to do with that. But that's probably we should figure out how to do that. And there is a good mail thread in the developer mail list where a lot of conversation was happening about what it is and how does it work. And basically, you need to study the source code. There is no currently a lot of documentation. So if you want, you need to go and read the source code. It's kind of messy right now. It's going to be better. At least I see that the Lars pushes the patches to clean up the source code, because the first time when I saw, like, what is that? It's hard to read. It's hard to understand what it's doing. But with his patches, it becomes much better. Yeah. So we will see. So thank you all for hearing me. If you have any questions, please unmute yourself and ask a question.